Okay, the reason I brought out a second unit circle is because if we put too much on one unit circle, it gets all cluttered and you don't know what anything means. This circle story is going to help you specifically with the signs of the different functions, SI, G, and S. Okay, so that's why I pulled this out separately. So we're studying the signs, SI, G, and S. So they have it all color-coded and everything. They even give you a little acronym to help you remember. And remember, memorizing is a last resort. You want to just remember from your previous experience the different signs in the different quadrants. As long as you remember that x is the cosine value, y is the sine value, and tangent is y over x, you got all the story. So they use greater than or less than zero signs. I like to use plus and minus, or plus and plus, well, plus and minus, but I'll go ahead and write it as an ordered pair. So it says for the first quadrant, the sine is positive, the cosine is positive, and at the tangent, if I take a positive divided by a positive, it's positive. So who cares, right? Who cares? So what? Well, in your homework, when you're working through the different angles, if you remember, the tangent of 45 is going to be the same as the tangent of 135 is the same as the tangent, they're all the same relationships. The only difference is the signs change. SI, G, and S. So they tag this first quadrant, all are positive. In the second quadrant, since the ordered pair goes negative, positive, they're just talking about the positive results. The sign is positive. That's this one. But the cosine's negative. And when I take a positive divided by a negative, I get a negative. So that's why they didn't talk about those. They're only talking about the positive answers. Does that look familiar? Except for we're tagging them with trig functions now. That's the only new idea, is that instead of x and y, it's cosine, sine, and then when you take the ratio, it's tangent. So in quadrant 3, everything's negative, a negative ordered pair. If I take a negative divided by a negative, that's where it comes out positive again. So if I ask you what the tangent of which one I could use, 210 degrees, the answer is going to be positive. That's why. Wherever the might have the same result if I took the ratio of two, of the x and a y, but since it's in the third quadrant, positive. And the last one, ordered pair, x is positive, y is negative. That means cosine is positive, sine is negative, and if I take a negative divided by a positive, it's a negative. So they created this little acronym. All students take calculus, so you can remember what is positive. And now I'm going to let you use all the resources outside of cheating for your final. But maybe your next level of mathematics expects you to remember these things quickly, so you'll be able to. This is just one more way to help remember things. Okay, so you got your pluses and your minuses on this paper. You've got your values of your angles on this paper. Let's go into some examples for this lesson. It's a whole class, right? Here at LHS. See if I can find my papers. Right? You can take it a whole year. That's how much information there is. In pre-calculus, you get a chapter or a unit, maybe. So in pre-calculus, you'll have to just learn it more quickly, and maybe not as deep. So when you go to that next level, at least you've heard of the words, right? And hopefully have a good experience with trig. It's a fun math. Anybody watch the eclipse last night?
Oh, it was so good.
Wasn't that beautiful?
Yeah.
There's a lot of trig going on in that thing. When they calculated measurements, a lot of trig, because there was nobody there. But the man in the moon.
I think you're right.
Okay, let's connect the dots. The signs are on this circle, but you just didn't notice maybe who was positive and who was negative. So that's why we went explicit with this one. Ordered pairs, positives or negatives, or both or neither. On this practice sheet, they're going to bring out a fact you've already learned, and they're going to create it as a trig function identity. And there's lots of them. If you're taking trig for a whole year, you'd probably see them all. If you're just taking it for a unit, you probably won't get to see them all, but you can derive them eventually because it all boils down to the Pythagorean theorem, where it's a squared plus b squared equals c squared. So instead of A, B, and C, they went to the unit circle. And I don't know why they started with the word sine. I'm sure there's a reason. But they went to y squared plus x squared equals radius squared, right, which is 1. So instead of an A, they used a Y. Instead of a B, they used an X. Instead of C, they used a 1. And squared it. Then they substituted in sine is whiny, so that's sine squared of an angle plus cosine squared of an angle is still on the unit circle, right? So they went from values to trig functions. So you already knew this. And all the identities you'll learn, I remember this. How did I remember it's an identity? Because it has a 1 in its story, and there's only one of you. That is your identity. There is nobody else like you. So that is a little memory trigger to know what is an identity. It has something to do with the unit of 1. So then what they do now? They took, and this is the beginning of all identities. They took this guy and they solved for a function and solved for the other function. And so those are the two we're going to use, as well as the tangent. This is not an identity, but if you don't remember what the tangent relationship is, you won't be able to do number 9 through, I don't know what it is, 16 or something like that. It's the sine function over the cosine function. All the time, every time, no exceptions. Now this one doesn't show up on this practice sheet, so we won't be able to talk about it until we get into the homework on that one. So So it's already something you've known. You've already known this. And here's where the Algebra 2 comes in. If you hadn't been through all of Algebra 2, you would not know how to solve for that value. You know, you wouldn't have had to know you could subtract both sides by the cosine squared of theta. You would have taken the square root of both sides to get rid of the squared. And now we're stuck in a dilemma in Algebra 2 that we know there's just not a positive root. It could be negative. So how do I know which one to use? Which quadrant does it live in? That's why I brought this in. So depending on what quadrant I'm in, that's the sign of my answer. S-I-G-N. That's confusing. So as you read the story, when they tell you what they give, you're going to use the one. You're going to use this formula to plug in what they gave you. And then how do you know which answer to use? It comes from this quadrant. So this is from pi over 2, which is at the top of the circle. Okay. From pi over 2 to pi is in quadrant 2. So I can put a Roman numeral 2 or a Q2, whatever I want to do. I'm just going to put quadrant 2 there. And so I look here, I need to find the sine function, and the sine in quadrant 2 is positive. So my answer is going to come out positive. So that's my little shorthand to keep me in the game. So the rest is calculator, guys. Rest is calculator. I'm going to give you a little I don't know what you'd call it. What do you call it on the video game when you get the cheats, you know, and let you go to a higher level? Are they still called cheats?
Cheat codes.
Cheat codes, yeah. My son showed me those silly things. Anyway, they're kind of handy, aren't they? They are. They are. So I'm going to show you. It's not cheating, but it is like a. If you know the rules of the game, you usually, whoever knows the rules of the game best, usually wins, right? Especially on the digital side. So here we go. Instead of hugging that negative number, then squaring it, any number squared is positive. So I can take a little less time and put in 1 minus 0.285 squared and get the same result. So that's a little quote-unquote cheat code or whatever you want to call it. Because I know when I square a negative number, it's coming out positive. It saves me 3 strokes on the calculator. So, and you can check it out. And if you're going, I don't know what you're talking about, and I'm going to put it in the way they say to put it in, just do it. Just trying to, I don't like calculators anyway, and if I have to use it, there we go. Save myself a couple of strokes. So see, I get the same answer. The calculator still gives you just the positive answer, and it did say I needed the positive answer, so there we go. That's where they came up with this. So this was in quadrant 2. So therefore it's the positive answer, not the negative answer. So what are you going to get wrong on the homework? You're going to round it wrong. That's going to happen. And you're going to put in the wrong sign. That's going to happen. You know, I'm just telling you everything I've done wrong. And so, and thankfully these last module assignments won't let you be wrong if you stay in the game. It's just your time. So the less you're wrong, the faster you can complete the idea and still understand what you're doing. Any questions about the shortcut? I like shortcut better than cheat code, but same thing. The quadrant and the rounding. They do not tell you what to round to. They use that word right there. PU, yuck. But in tech math and, you know, higher levels of math that I've taught before, if they don't tell you what to round to, you round to the number of significant digits that your question has. So right there, there's three decimal places rounded. So here is where they got the 3 decimal places rounded. So that will give you a ballpark on what they want. Now again, if like the last lesson, you might not round as much as they round, and so you're going to wrestle with the rounding until you get it right. Same with this lesson. So be careful just on the rounding. Okay, so that is. Let's do it. Okay, they give me the cosine, so I'm going to use the sine formula. And the good thing is, the only thing that changes is what's out here and what's in here, right? 1 minus, and then I just put in my decimal without parentheses, because when I square a positive number or a negative number, that still comes out equal. And then I note that this is in the first quadrant, so my sign is positive. Everything's positive in the first quadrant, remember? All trig functions are positive in the first quadrant. So plug and chug. And since I have 3 decimal places here, I'm going to go ahead and put in 3 decimal places there. And it's positive. So, yay, done. So they give me a sign, so the cosine's what I'm looking for. That's a big deal, because you're going to know what, you know, which quadrant it is, what sign it is. Isn't this neat how this works? Oh, no parentheses. I'm just going to put in a 0.548 squared. Okay. And let me see. Pi over 2 is at the top. Where's my unit circle? There it is. Pi over 2 is at the top right here. And then go into pi right here. So I'm in the second quadrant. Quadrant 2. And then pretty soon you do this enough, you won't have to look all the time. So I'm going to look at the cosines. Cosine in quadrant 2 is negative. See that? Cosine's the x values. Only the sign is positive. So I'm going to put my negative answer. So right now, I'm going to write a negative down so I don't forget. And I do the calculator, and it's 0.836. Notice on a unit circle, the decimals are always less than 1. You know, the absolute value of the decimals are always less than 1 because you're finding the size of a triangle whose hypotenuse is 1. And 1 is always the longest side. Tangent can be greater than 1. You will find that out in homework. Sad to say, though, they did not have tangent example here. Okay, so I'm looking for the sign. I'll quick finish here. 1 minus, and I'm just going to put in 0.403 because if I square it, it's going to come out a positive number anyway. Pi to pi 3 over 2, that's quadrant 3. Everything's negative in quadrant 3 except for tangent. So that's my answer. I'm going to go ahead and write a negative out. Do the calculator, and 0.915. I will stop there. I think that's enough. You guys want to do the homework? You can do the homework 1 through 8 without me. If you're feeling time crunch because Friday's the deadline, you can sure check out a calculator.